to show you two different algebraic ways that we can solve a system of linear equations. So the first one is using substitution. So the steps in substitution are, the very first thing is we need to solve one of the two equations, so one of the equations for one of the variables. Now, you want to be strategic in which variable it is that you want to solve for. And sometimes I'm going to say we want to isolate. That's another way to say solve for one of the variables. Okay. So once we pick one of the variables in one of the two equations that we are going to isolate, we are going to take that like other side and substitute it into the other equation. So, and once we do that, what we'll have is one equation with one letter in it. That's a great place to be because that means we can solve for that variable value. Okay. Once we know what one of the variables, what number it's supposed to have, then we're going to go back and plug it in, plug the number we found, plug that value into one of the equations to get the other variable. Okay. It's a lot easier than that sounded. So let's go ahead and take a look. So here's a system. So x plus y equals 6 and 2x minus y equals 0. We need to solve for one of those four letters that we have. There are three really good choices and one not as good choice. Can you all decide which one would be the not good choice? Yeah, right? Solving for that x in the second equation would be kind of obnoxious because we're going to have to, right, end up dividing by the 2. We would create a fraction. Well, we don't want to do that. We don't have to because I've got, right, 3 other letters that are perfectly good to solve for. So let's go ahead and just arbitrarily pick that top x, right? So the x in the top equation. We want to get that x all by itself. So that means x plus y equals 6. I would subtract y from both sides. So I'll go ahead and write it over here. X plus y equals 6. We're going to solve for the x. So we're going to subtract y from both sides. So x is the same thing as 6 minus y. Okay, so that's step 1. Our next step is we are going to substitute it into our second equation. So we're going to take the 6 minus y and plug it in for the x in the second equation. So that is going to be 2 times 6 minus y, right? That's what x is equal to. And then I have minus y equals 0. So this equation only has y's in it. So we're going to go ahead and solve for that y. So distribute your 2, combine like terms, constants on the other side, right? Just like we've done. So 12 minus 2y minus y equals 0. 12 minus 3y equals 0. I'm going to add my 3y to the right side. So now I have 12 equals 3y. Kind of running out of space. Pop up here. So if 12 equals 3y, then y equals 4. Hey, there is step 3. We know the y value. Remember what our solution looks like? It's going to be that ordered pair. So I know the y part. Now I just need the x part. So I'm at my last step. To finish, we're going to go back, plug in the value we found into one of the two equations, come up with the other letter, right? The other value. So in fact, I'm actually going to take this one that we already manipulated. So x is equal to 6 minus y. So in this case, x is equal to 6 minus 4, right? That's what y equals. 6 minus 4 is 2, and there is the x part. Now, depending on your online homework system, right, maybe they will want you to write it as an ordered pair, so 2 comma 4, maybe just x equals and y equals. Figure out what form you're supposed to have and do that. In our second system here, negative 3x plus 3y equals 10, 4x plus y equals 5. There's only one good choice to pick there, right, if we're going to do substitution. Right, exactly. So we're going to solve for that y in our second equation. So I'm going to subtract 4x from both sides. So y is equal to 5 minus 4x. So once I've done that, I'm going to take the right side version of that. So y is the same thing as 5 minus 4x. I'm going to go to the other equation, the one we haven't used yet, and plug that in place of the y. So now I'm going to rewrite that top equation. The negative 3x stays the same, plus 3 times y, but y we now know is equivalent to 5 minus 4x, and that all equals 10. So then we're going to solve this. There's, right, one equation, one unknown. That's awesome. Negative 3x, distribute your 3, so plus 15 minus 12x equals 10. Combine your like terms, so negative 15x. I'm going to subtract the 15 from both sides, equals negative 5. Divide both sides by negative 15. So I have negative 5 over negative 15. Negative is positive, and that's 1/3. So there's your x part. Now to get your y part, we take this x value, plug it into one of the equations. I'm actually going to not take the way I did last time, because I see now if I plug this 1/3 in for the x in the top equation, I can get rid of the 3, because this 3 will cancel that 3 that's going to go in. Okay, that's what I'm going to do. I'll grab a different color so you can kind of pull it out there. So I'm using my top equation, negative 3 times x, but x is 1/3, plus 3 times y, and that equals 10. So now we're going to figure out what y is. I already found x. So the 3's will cancel. Negative 1 plus 3y equals 10. Add 1 to both sides. 3y equals 11. Divide by the 3. So the y equals 11/3. So the ordered pair version, right, x goes first, 1/3. Y goes second, with parentheses and a comma. Okay, to do elimination, what we want to do, right, our goal is to make one of the variables disappear, kind of like what we just did in substitution. So the strategies are, we are going to multiply one or both, sometimes we'll have to do both, equations by a constant, a number, so that the coefficients, number multiplying, one of the variables are equal and opposite. So same value, but different signs. So positive 2, negative 2, positive 5, negative 5. Okay. Then next, what we do is we're going to add the two equations together. So as long as, right, you have two equations, and I think of this like a teeter-totter balanced at the equal sign. Okay. If both equations are balanced, to start with, you can add these two sides together, right, the two left sides and the two right sides, and you'll come up with an equation that is also in balance, right? So that's what this add the two equations together step lets us do. Solve what's left. It should be one equation with one letter. And then, so right, that's kind of the same step 3 we had for substitution. Once you've done that, you can either, right, we still need to get the other variable value. We have one variable so far solved for. We have to get the second one. We can do that by eliminating to eliminate the other variable. Or we can substitute, just like we did substitute, like we did on the last step on the top version. So here we go. We're going to solve this system. 4x plus 2y equals 3, x minus y equals 7, and we're going to use elimination. So when I look at this system, I have a positive 2y here and a negative y here on the bottom. So if this were a positive 2y and a negative 2y, if I would add those together, the y's would go away. So that's what I'm going to do. So I need to change this negative y into a negative 2y. So I'm going to multiply both sides of that bottom equation by 2. Top equation, I'm not going to do anything to. I'm just going to copy it down, copy it across. So for the second equation, or the bottom one, the 2 distributes on the left. 2x minus 2y equals 14. So this equation is equivalent to the one we started with. It's just been scaled up so that, we're on step 2, when I add these two equations together, the positive 2y and the negative 2y, those go away, and I get 6x, 4x plus 2x, and then on the right side I get 3 plus 14, 17. And then solve for x. So divide both sides by 6. X equals 17/6. Okay, I've got my x value. I've done step 3. Finally, you're either going to re-eliminate to get rid of the, right, in this case it would be to figure out what y is, or we can substitute. Now, 17/6, I'm not looking forward to plugging that in anywhere. So I'm going to go ahead and do the elimination process again, except this time I would need to get rid of the x's. Okay, so I'm going to start back at the beginning. 4x plus 2y equals 3 and x minus y equals 7. So what would we multiply by to make the x's disappear? So I have a 4x on the top. I would need a negative 4x on the bottom, right? So I would multiply both sides of the equation. I'm going to kind of cheat here. I'm going to just make my parentheses super big. I'm going to distribute a negative 4 through the entire equation, okay? Top equation stays just as it was. No manipulating there. Bottom equation, the negative 4 has to multiply all three terms. So I'm going to get negative 4x plus 4y equals, what is that, negative 28. And now we'll add them together. The 4x and the negative 4x go away, become 0. And then I have 6y equals negative 25. And divide both sides by 6, so y equals negative 25/6. You should, right, when you have these ugly, I shouldn't say ugly, when you have these fractional answers for your solution, your system, the denominator should be really related. So 6's, right, both 6's, or maybe a 6 and a 12, that would be okay. But you shouldn't have a 6 and a 7, right, for one of the denominators. They're almost always related. So the ordered pair version, 17/6, comma, negative 25/6. Okay, this one here is an example of where we have to multiply both equations. So I'm going to multiply let's get rid of the x's first. Okay, so 3x and 5x. I need those to have their coefficients to have the same value but opposite signs, right? So that would be, it's kind of like finding a lowest common denominator, right? The least common multiple. So 15, right? So I'm going to have the top one be positive 15. So that means I have to multiply the top equation by 5. And the bottom equation then would be multiplied by negative 3, right? So look ahead and see what that's going to do to your x coefficients. The rest of it, right, it's going to get, right, bigger as well. But that's just what we have to do. So the 5 distributes through the entire top equation. So I get 15x minus 10y equals 35. And for my bottom equation, I'm going to get, so remember it's a negative 3 that's distributing. So I'll get negative 15x. Negative 3 times negative 3y is plus 9y. And then I get equals positive 12. Okay, so we're going to add those two equations together. The x's disappear as they're supposed to. Negative 10y plus 9y, that's negative 1y, equals, those were both positive. I'm just checking on my algebra there. Looks okay. 47. So that's okay for negative y. For positive y, then would multiply both sides by negative 1. It just changes the sign. Oh, shucks. Oh, I guess that's right, negative 47. I was thinking it was going to be some fraction, but it was not. Okay, y is negative 47. So then to find x, should we just plug that back in? Sure, why not? Okay, so I'm going to take the top equation. So I have 3 times x minus 2 times y, which is now negative 47. And that's supposed to equal 7. I'm going to grab a calculator because that math looks kind of obnoxious. The 2 minuses will make a plus, but 2 times 47 is 94. So 3x plus 94 equals 7. Subtract 94 from both sides. Looks like negative 87. So 3x equals negative 87. And then divide both sides by 3. So x equals negative 29. And then ordered pair version, which I'm sure you've already done. Negative 29, right? X goes first, comma, negative 47. Okay, so I just want to show you, again, the 3 different types of solutions that you have. So one unique solution, that's what we've been seeing, right? All of those examples, we came up with an answer, a single answer in that. Remember, if you were looking at it graphically, that's the point where they intersect. When we get, format for writing the solution set, it's just that ordered pair. Infinite solutions. So when this happens, what happens algebraically is that all of the variables kind of disappear in your solution strategy, but what's left is true. And remember, infinite solutions, this is where we get the same line, just different versions. It just graphs on top of itself. So here's an example. So 6x plus 2y equals 8, and 3x equals 4 minus y. So let's say we're kind of going to go along our path and solve this system. So I would solve for y. I don't write substitution, elimination doesn't work well for me when they're kind of across from each other like that. So I would, I'm going to solve for this y right here. So I'm going to add y to both sides. So now I have y plus 3x equals 4. And then subtract 3x from both sides. So y equals negative 3x plus 4. No, you could have written it the other way. That was fine. So I was manipulating the second equation. I've solved it for y. So now I'm going to take the right side and substitute it into the other equation. You don't want to use the same equation that you just manipulated because you get in an endless loop. So use the other one. So 6x plus 2 times y, which is now this other version, equals 8. So we're kind of going along our merry way. 6x, 2 times negative 3x is negative 6x, plus 8 equals 8. 6x minus 6x, those guys add out. 8 equals 8. I have no variables, and what's left is a true statement. This is the situation where these two lines are actually the same line. They've just been scaled. Okay? So the solution set is any point and every point that's on that line. So the way we write that solution set, it's set builder notation. So we use our curly Q braces, and we say it's the set of all of the points, so a point, x, y, such that, and then we just describe the line. So you would just grab one of those equations, right, and write it in. You could have written the other equation just fine. Now, for the third thing that can happen is that, right, we have no solution. Right? We have that inconsistent system when you have parallel lines. So when this happens, all of the variables disappear, just like it did in the last example, but the thing that's left is not true. Okay? So let's go ahead and try it on this guy right here. So I will solve the top equation for x. So x equals y plus 14. I would substitute y plus 14 then into the second equation. So 7y equals 7 times x, but x is now being played by y plus 14 minus 3. Go ahead and solve, right? One equation, one unknown, that's good. So we're going to try to solve for y. So I'll distribute the 7y plus, let's see, what is 7 times 14? It is 98. Minus 3, gather your y's on one side, so subtract 7y. So we get 0, right? Those guys go away, and those guys go away. So 0 equals 98 minus 3, 95. All the variables are gone. This is not true, right? This is a false statement, not true. So, format for writing this solution, we would just say there is no solution. Right? There are no x, y values that are common to both of those lines.